Hello gentlemen, hope you are doing good. Today in this video we are going to learn length.
So gentlemen, let's start with the length contraction. So for this, first of all let us make a diagram. So this is our y-axis, this is our z-axis and this is our x-axis, and this is y dash, this is v dash, and this is our x dash. This is a stationary frame of reference and this is a non-stationary frame of reference named S dash. Now suppose we have a rod of length L which is placed in non-stationary frame of reference. This is its starting and end points. Now this distance from x-axis to the last point of this rod length is x2 dash and this distance is x1 dash, and distance of this end point from stationary frame of reference is x2 and this distance is x1. So we have x2 minus x1 equal to L0 and x2 dash minus x1 dash equal to L. Now in our last video we have derived Lorentz transformation equations and from them, so according to Lorentz transformation equation, x dash equal to x minus vt upon 1 minus v square upon c square under root. So we have x1 dash equal to x1 minus vt upon 1 minus under root v square c square, and we have x2 dash equal to x2 minus vt upon 1 minus v square upon c square under root. This is our equation number 1. This is our equation number 2. Now from equation 1 and 2 we have x2 dash minus x1 dash. Putting the value of both the equations, we have x2 minus vt upon under root 1 minus v square upon c square minus x1 minus vt upon under root 1 minus v square upon c square. Now subtracting both the equations, we will get x2 dash minus x1 dash equal to, as it has both of them have same denominator, so we will subtract them directly. So xvt and vt cancel out each other because minus minus it become positive and they will cancel out each other. So we will left with x2 minus x1 upon 1 minus v square upon c square. And now according to A, let us take them as equation number A. So we will have L equal to L0 upon 1 minus v square upon c square under root, or we can write it like L0 equal to L into 1 minus v square upon c square under root. So this is the formula of our length contraction. So after deriving this formula, we have what we get is that L is smaller than L0 by a factor of under root 1 minus v square upon c square. And second thing is that now moving forward to time dilation. So again we have diagram This is y-axis, this is z-axis, this is x-axis, this is y dash, this is z dash, this is x dash. This is a stationary frame of reference S, and this is a non-stationary frame of reference S dash. Suppose we have a clock here having time 3 o'clock. Give it in a name like clock 1, and we have another clock 2, which should have time 3, but it is slightly moving in a different way, or it is slightly slower than the clock which is situated in stationary frame of reference. So let me brief you this. A clock moving with uniform velocity v relative to an observer appears to him go slow by a factor of under root 1 minus v square by c square. Then when it rests relative to him, the effect is called time dilation. Now on applying Lorentz transformation equation which we have derived in our yesterday's class, so t equal to t minus xv upon c square upon under root 1 minus v square upon c square implies t1 dash equal to t1 minus xv upon c square upon 1 minus v square upon c square under root. Similarly, we have t2 dash equal to t2 minus xv upon c square upon under root 1 minus v square upon c square. Now from equation number 1 and equation number 2, we have t2 dash minus t1 dash equal to t2 minus xv upon c square upon 1 minus v square upon c square under root minus t1 minus xv upon c square upon 1 minus v square upon c square. So both these terms will cancel out each other. After this negative sign multiply with this, it will become positive, and they both cancel out each other. So we will left with t2 dash minus t1 dash equal to t2 minus t1 upon 1 minus v square upon c square under root, and we have t2 dash minus t1 dash equal to t, and t2 minus t1 equal to t naught, where t is dilated time and t naught is proper time. So we will left with t equal to t naught upon 1 minus v square upon c square. This is derivation of time dilation, and we can conclude that t naught equal to t into 1 minus under root v square upon c square. So we can say that since v is smaller than c implies 1 minus v square upon c square under root is smaller than 1, hence t is greater than 0. Now example of length contraction and time dilation. Example, length contraction. Suppose a car with at rest having length L when it is in rest seems to be large, but when it is in motion moving forward seems shorter by a factor of under root 1 minus v square upon c square. An example of time dilation is suppose when you send suppose you have a twins, one who is stay on the earth and one who is went in the on any other planet or for any for in the universe. Relation is, suppose you have twins, one who is staying at earth and one you have sent as an astronaut for 10 years. So after 10 years you will see that the one who is staying at earth is more older than the one who is went or go as an astronaut. So this is the example of time dilation. So this is all about this topic, gentlemen. Hope you understand this topic. If you want some more numericals on this topic, do comment below, and please subscribe to my channel, like the video and share among your friends. If you have any suggestion.
In our next video, we will learn velocity addition theorem. Thank you.